Hey everybody, welcome back. Part 6 in object-oriented programming in Apex. Really can't believe we made it this far. It's been a couple of weeks since the last video, so I apologize for that. Things have been pretty crazy busy on my end. Alright, so today we are going to talk about inheritance and virtual classes in Apex, right? And how that works. And I think they're key concepts to understand, right? I always say, like, Apex is an object-oriented language, but a lot of Apex developers are not doing object-oriented programming. And I think this sort of knowledge is really important to set yourself apart professionally. So this is going to be, we're talking about virtual classes. Inheritance, we're going to do really simple examples. I think next video, we will do a much more like a real-world use case for virtual classes, which is trigger handlers. And then we'll probably move on to start doing some abstract classes and show you what is the difference between inheritance with virtual versus inheritance with abstract, and what do those keywords all mean, right? So again, we got, if you remember when we started all this, 4 fundamentals, 4 pillars of object-oriented programming. That was abstraction, encapsulation, polymorphism, still my favorite, and now inheritance. So let's get into it. Let's talk about what inheritance really is, right? So back to Stackify, where we've used in every part of me. I'm going to get something to drink. Sorry. It is one of the core concepts. I may have to edit this out later. One of the core concepts of object-oriented programming languages. It's a mechanism where you can derive a class from another class for a hierarchy of classes. So it's from classes to classes and a hierarchy of classes that share a set of attributes and methods. And in my opinion, I think if you understand inheritance, you've worked with inheritance, that makes sense. If you are trying to learn inheritance, you are a beginner, I think that's like as clear as mud, because I use inheritance all the time, and I'm kind of like, oh yeah, sure, that's what it is. But it makes sense. It makes sense, and hopefully it'll make more sense to you when we really do it. So that's it. I think the fastest way to get up to speed on this one is not to talk about it and just to do it. Again, right, we're going to do super simple example. So if you're coding along with me, I'm going to say I'm using Illuminated Cloud plugin with IntelliJ. And I guess many years later, right, I always think when I was starting, and I'd watch David Liu's videos, and he was using Maven's Mate, which isn't even supported anymore. But he would talk about, right, your editor, it's a personal choice, and there's no real right or wrong, but if you're not using Maven's Mate, you are wrong. I feel the same way, right? A lot of good options out there, and no right or wrong, but clearly if you're not using Illuminated Cloud at IntelliJ, you're missing out. And I'm going to see it is paid. I am just an advocate for it. Like, I am not sponsored. I get nothing from it. 30-day free trial. Check it out. See what you think. So I am going to go, we're going to create a class called Animal. And there we go. And I guess I'm going to start with, I always swore if I ever got to some point in my career where I was teaching these sorts of concepts, I would not teach inheritance with animals or cars, because I feel like every OO class in the world uses animals and cars, and here I am, right? Because you know what? It's kind of simple. It's easy to understand. Everybody can relate to it, and you know, obviously, right? And in your career as an enterprise software developer, you know, one of the things you are going to do every single day is write objects, write classes that mimic animals, right? I can't, you know, I mean, who doesn't do that every day? So we got our animal class. Just kidding. You're never going to do it. Most of your classes that you write on the job are going to be much more abstract. All right. So we have an animal product, and I'm going to say we need to give our animal class some oh, you know what? Like, this is really important, right? Virtual. Like, nothing's going to work without. So that's the important difference between every other class we've created so far, is that virtual keyword. That's what is going to give us our inheritance. So now let's give our animal class some property. So I'm going to say string name. And we're going to do, we'll just give it some getters and setters. set. Oops. And what else? So, and if anybody out here is a biologist or something and you're watching this, I apologize. Right now, I am not making light of what you do. I'm just ignorant, and I'm sure I should be using, like, I don't know, vertebrae or invertebrate or something here, but I'm not that smart. So we're gonna say I'm just making stuff up. I don't know if these are really properties of all animals. String. I'm gonna say all animals have a weight, though, right? So integer weight, right? We'll make that private. Set. And what else? All animals, I'm going to say, have an age. Right? Yep. Set. All right. So now we need to create a constructor for our animal class. So we're going to say public. And if you did not watch, I think it's the very first video in this series, a constructor is just a very particular kind of method. It is a method that has the same name as the class, and it has instructions. It's the instructions on how to construct the object, how to set up these properties and things. So we're going to say string name, integer weight, and integer age. And then we're going to say this dot name equals name, semicolon, this dot weight equals weight, and this dot age equals age. All right, there we go. We've got our animal, we've got a constructor. So now next thing is we should give our animal some class, some methods, right? So it has things it knows, and the methods are things it can do. So we're going to say public void make sound. All animals can make a sound. Says I. Don't know if that's actually true or not. Well, you know what? We're going to change that. I'm going to do this. Make it even fancy. We're going to say this dot name. Oh, we got to put a plus in there, though, right? It's going to blow up on me. Makes a sound. All right. And now let's see, public void. We're going to say all animals can eat. Public virtual. So notice I'm adding the virtual keyword in there. And this may be something you have not used. This virtual keyword is maybe something you haven't used before in your Apex programming. All right. So I'm hoping that it'll all make sense when we get to when we actually really get into inheritance. Eat. All animals eat. And we are just going to do simple debug statements, right? Animal is eating. All right, and we're going to do one more. Got to make it void, right? Because it's not returning anything. Public virtual void. And then we got to do one more. Public virtual makes sound eat. All animals have to move, right? They can all move in one way or another. Keep forgetting to add my void in there. Get into the right spot. System.debug. And we'll say animal is moving. All right, let's compile that. I'm not sure what that was all about. No deployment response found. There we go. All right. For some reason, I don't know if I need to reboot or do something with my machine. I seem to be sucking up a lot of memory lately. So we're just going to say animal. So it's a fish, right? Equals new animal. And we got to give it a, so we'll say Goldfish. It's 1 year old and weighs 5 pounds. That's a really big goldfish. But I made it an integer, right? Not a float. So now we'll just say fish dot makes, just to make sure it all works, right? Fish dot make sound. Let's run them, do our debug only. We're just down here in our anonymous Apex. All right, the goldfish makes a sound. So, I mean, it worked, right? We created an animal class, and the issue is this isn't really very flexible. So we have an animal class. Now, what happens if I want to actually, because I mean, a goldfish is, so we could say like all these animals have things in common, right? They have a name, weight, and an age. And they all make a sound, they all move, they all eat. But a goldfish doesn't move the same way a dog moves, right? I don't know if a goldfish makes a sound. Doesn't I don't even know, right? So what would we do? I mean, I guess we could just make an animal class, or we could make a goldfish class and have it all the same. So we could, in fact, we could, and then make a dog class and a giraffe class. And they would all have, make sound, eat, and all these same properties, right? But we're repeating ourselves a lot, right? We are going to start creating a lot of really repetitive code. And right, one of the fundamental rules in software development, dry, right? Do not repeat yourself. So inheritance allows us to work with things that have, and what I'm going to say, an is a relationship. So what I mean by that is a dog is an animal, or a zebra is an animal. So they all have these certain things in common, but maybe they need to be implemented slightly differently. So we are going to now create a dog class, a new class, and we'll see what that looks like. And we're going to create a dog class that inherits from animal to show you what, hopefully then this will all make some sense to you. So public with sharing class dog. Now here's the extends animal. And this is right there, that extends, that is where the magic happens, right? Dog just inherited everything from animal. So to show you that, so in this case, right, because a dog does not, because our animal does not have a default constructor. So let's just say we're going to step through this, and we're going to do our inheritance very deliberately. Public dog, and we're going to say string name, integer weight, and integer age. Okay. Curly braces, right? But now, instead of doing like, what we would write, this dot name, because right there we didn't even create a name property on the dog. What we're doing, because we extended animal, that means we inherited animal's the constructor in animal. So we're going to say super, and this is so animal is our super class, and dog is our subclass. So in this, we are going to call the super class, and we're going to say we're going to pass these values: super name, weight, age. Let's compile that. All right, so now I'm going to get rid of our fish down here. And I'm going to say animal dog equals dog. First, I would make sure to say there's not only inheritance going on here, there's polymorphism, right? Because the inheritance allows dog to take on the type of animal. So anything that inherits, extends animal, can be substituted in. So if we had a factory, right, that returned animals, anything that extended, or anything so that it could return dogs and cats and lions, tigers, and bears, right? So let's just, we're going to give it, first I'm going to I have a Australian Kelpie puppy named Eno, who's 7 months old. So I'm going to say 7, and I'll say she probably weighs about 30 pounds now. And now I'm going to say dog dot make sound. And dog dot move. And what I want you to know is nowhere in here did I assign properties in my dog class, and my dog class does not have any of those methods. It does. So we're going to say we're calling dog.makeSound dog.move. But those methods are not found in the dog class right now. Let's run it. All right, so look at that. Eno makes a sound, and the animal is moving. So that this is our most basic inheritance, right? Because remember, dog extends animal. It inherited the constructor, and it inherited all of the methods. So everything that was in animal, dog got without us recreating, which is it's pretty cool. I have to say, like the first time I saw this, I was like, oh wow, like that is awesome. So now but now, like I said, so we dog extends animal, but dogs are a little different. So we're going to say our dog has a string dog, a breed. All right. Get, and we'll do a private set. And we'll say all dogs have a color, string, color. So we're going to give dog a couple properties of its own that animal doesn't have. Private set. All right. So now let's modify our constructor. String, breed, and string, color. Okay. So remember before, so we are still using our super. We're still saying, hey, these first three properties are found in the animal constructor. So call the animal constructor, send it these three values. But in the dog class, when we create a dog object, this dot breed equals breed, and this dot color equals color. All right. So now we'll go down here back to our anonymous apex because it said, hey, like we don't have this constructor is not valid anymore. So Eno is an Australian Kelpie. We'll just say Kelpie, and she's kind of tan. All right. Now, so then we'll just do system.debug dog. All right. And we get that. So I thought maybe we'd be able to, that is clearly not going to work. Why compile failure, constructor not defined. All right, let's see if we can turn this into a teachable moment. Line 1, breed age 30. I am just got, in case I didn't. Did I compile this? Did I not compile it? Let's try it again. Animal, I'll say animal dog equals new dog. All right, and we'll say her name is Eno. All right, and she is 7 months old, so we're just going to say, let's say 7, whatever. So about 30 pounds. She's a Kelpie. And she's brown, brownish tan, whatever. All right, now we'll say dog dot eat. Dog, not dog, dot move. And dog dot make sound. Okay. All right, so so you see now step 2 in our inheritance, right? We added a couple properties to dog that were not on the animal superclass. We still called the superclass constructor, and then we set the properties that are unique to dog down below in the actual dog constructor. So this is a call to the superclass constructor, passing it the name, weight, and age values, and then we're going to set the values in our subclass. And now, so we're going to, what were the methods? So if we look at go back to our animal, you notice we had 2 methods, eat and move, with virtual in them. So what that means is when a method is declared with a virtual keyword, that means a subclass can override it. So because dog extends animal, we could say public override void eat. And we'll just say the dog is eating. Let's just see what that looks like now when we run it. How about I do that in a system debug statement? Wouldn't that be amazing? Recompile. You're getting me on my best day, folks. And now we got a semicolon in there because I can't even copy and paste correctly. All right, let's run this again. All right, so the dog is eating now, right? So we overrode the implementation of eat in the animal superclass, right? Animal is, let me get that out of the way, has just a, right? The animal is eating. And dog, we called override on the virtual method and changed it to the dog is eating. At Portnerson, because make sound, right? Make sound is not virtual. So we cannot override something. It has to be either virtual or abstract. So we can't override make sound. Every class that extends animal will get the make sound method, but they cannot override it. They can't change it at all. And we're going to do a public override void move. We're going to override the move method. And once again, we can call the superclass. So maybe we did want to actually use the implementation of move that we find in animal and then make it just a little bit, I don't know, then add something else on for dogs, right? So we'll say system debug. To play fetch. Okay. And boom, back to anonymous apex. Let's bring this up. Let's run it again. All right, so now you see the animal is moving to play fetch because we called super.move. So we called the implementation of move in the superclass. And then we had something a little bit different in our subclass. So if you remember, I don't even know what playlist it's in. I think it's actually in object-oriented programming where we talked about the call stack, right? So we called super.move, right? So control left dog. And the animal move method went onto the call stack, right? So once where is it in there? Animal.move ran, right? Then that method was popped off the call stack, and we then ran the system.debug to play fetch in the dog implementation. So I hope this is all starting to come together for you and make some sense. We'll do more inheritance in the next video. If you want to study this a little more on your own, do a little homework, I would recommend thinking of other things, whether it's animals or cars or airplane, I don't know, stuff where you could use inheritance. Maybe it's actually something in your real work. Remember, inheritance is used to model a relationship. So a dog is an animal, right? So a dog can inherit from animal, but we would not use leash, right? Because a dog has a leash. That's a whole separate thing. We'd use composition for that. So we'll show you another video on how composition works. So, and a lot of times you'll hear say, that typically you should prefer composition to inheritance. Other thing I'd suggest you study if you're trying to get a grasp on inheritance is the Liskov substitution principle. And I got typos all over in there, but that's okay. The Liskov substitution principle and the SOLID principle of software development, right? Understand how the Liskov substitution principle fits into SOLID. So that's it. That is Intro to Inheritance, Intro to Virtual Classes in Apex. Hope this was useful. Let me know what you thought of in the comments, and please give me a like and a subscribe if this was useful for you, and I'll see you in the next video.